Nicole Hollins.
We're working on a project about the effect of coffee on sleep. The purpose of this project was to discover if coffee affects sleep, specifically if there's a correlation between the amount of coffee a person drinks each day and the number of hours that a person sleeps at night. A questionnaire was posted on social media account targeting a demographic of primarily females from ages 14 through 20. The survey contained 5 questions. 1. What gender do you identify with? 2. How old are you? 3. If you drink coffee, how many cups of coffee do you drink on average per day? 4. Do you prefer iced or hot coffee drinks? 5. On average, how many hours of sleep do you get per night? However, only question number 3 and 5 were utilized to obtain results. For accuracy, 2 types of statistical analysis were performed, an independence test and regression/correlation coefficient significance test. Results were recorded and data was analyzed. It was proven that there is a relationship between coffee and sleep. To basically give a background on coffee, coffee is a beverage with a universal appeal. It is enjoyed by consumers across the world due to its broad availability and enjoyable stimulation of the central nervous system. Although coffee drinkers tend to be older, there's a significant population of younger individuals who consume coffee. In fact, according to a recent survey published in the Grant High School Yearbook 2015-2016, out of 100 respondents, 31 drink coffee in the morning. Even though the survey excludes the individuals who drink coffee later in the day, it still supports the notion that coffee is America's favorite drug. Coffee is a normal part of many people's daily routine, with around 180 million of us starting most days with a caffeine jolt to get going. Coffee's main ingredient is the drug caffeine, a stimulant found in more than 60 plant species that grow in the tropic or subtropic regions of the world. Daily intake of caffeine is proven to associate with many health issues, one being lack of sleep. The purpose of this project was to discover if there's a correlation between cups of coffee consumed per day and hours of sleep per night. 2 hypotheses were formed. The first one predicted that coffee and sleep have a negative correlation, and the second predicted that coffee is dependent of sleep. As we look at the demographics, we can see the gender of participants is 19% male and 81% female, while the age of participants has more of a range. 14 through 15 is 6.25%, 16 through 17 is 45.31%, and 18 through 19 is 40.63%, while 20 and above is 7.81%. As we shift down to the descriptive statistics, we can see a brief overview of the data that was collected. The results show that out of the 64 people surveyed, the average amount of coffee one consumes daily is 0.7656 cups, and the average amount of sleep one receives per night is 7.0156 hours. The mode for the cups of coffee per day is 0, implying that the most common value represents participants who do not consume coffee. The mode for hours of sleep per night is 7, implying that the most common value represents participants who sleep 7 hours per night. The values for cups of coffee per day range from 0 to 3 cups, while the values for hours of sleep per night range from 4 to 9 hours. One of the tests we used was tests for independence. Our null hypothesis was coffee is independent of sleep. Our alternative hypothesis was coffee is dependent of sleep, and that was our claim. Our chi-square value is 10.65, and our critical value was 9.488, meaning that we rejected the null hypothesis and there's sufficient evidence to support the claim that coffee is dependent of sleep. We ran linear regression statistics and figured out that the correlation coefficient, the R value, is negative 0.432, and the coefficient of determination, the R squared, is 0.187, and the adjusted R squared is 0.174, and the standard error is 1.005. The N value is 64 as well. The correlation coefficient R implied that it was a negative/moderate correlation. The coefficient of determination R squared implied that 18.70% of total variation hours of sleep per night can be explained by number of cups of coffee consumed per day. The slope implied that when the number of cups of coffee consumed per day moves up by 1, hours of sleep per night decrease by 0.5 hours. Additionally, the intercept implied that when there is no coffee consumption, people get 7.399 hours of sleep per night. As you can see, here's our linear regression graph. Y equals 7.399 minus 0.5x. Our residual plot was not didn't have a pattern, thus it implied that it was normal. To further our data, we did a test for significance. Our level of significance was 0.05, our null hypothesis was rho equals 0, our alternative hypothesis was rho is not equal to 0, and that was the claim. The test statistic was negative 3.78, the critical value was plus or minus 1.67, and the DF was 62. As you can see, here is our curve. Since the test statistic was in the critical value, we rejected the null hypothesis. So, it implied that correlation is significant. However, note that a relationship can be moderate but significant. For large samples, it is easier to achieve significance, and one must pay attention to the strength of the correlation to determine the relationship. However, we might have experienced a type of...
Let's talk about bias, baby!
The project contained multiple biases. Firstly, a non-random sampling was used to gather research. Data was obtained from a female group member's Instagram account, which has a following of 772 people, the majority of them being a large percentage of female high school students. This also supports the notion that there was a convenience bias due to the easy accessibility and proximity to the group member. Another issue we came across was the fact that our survey was voluntary, meaning that our participants had to be willing to volunteer. As the demographic of the participants were calculated, it was discovered that 81% of participants were female and 45.3% of participants were of the ages 16 through 17. Thus, the results do not reflect the general population. Without a diverse sample of participants, the project lacks a clear result. If there was a larger population of adults surveyed, the results would have been more accurate. Another factor that wasn't considered was that the notion that people don't only sleep at night, but sleep during the day as well. The survey excluded the fact that there's a possibility of people taking naps during the day. This was valid information that was accidentally left out of the questionnaire. The data could have been skewed because of this factor. Additionally, the survey ignored the idea that people do not only drink coffee to receive caffeine, but they consume tea as well. Instead of just analyzing the effects of coffee on sleep, all caffeinated consumption should have been taken into account. Due to the excessive number of flaws, future surveys would need to diversify the sample group using an unbiased and random group of participants. Another improvement would be to triple the sample size and reach out to a larger group of people, helping to make the data and results as accurate as possible. For our first time running a statistical survey, as a collective, our group did a decent job of finding data. For any future survey projects, we will do a better job collecting data because that is vital to our results and project outcome. With a larger number of participants, we are less likely to result in a type 1 error. Another adjustment that we can make is to spend more time identifying a question that cannot be answered right off the bat, or that requires an experiment to come up with a conclusion. That way, we can have a more in-depth project where we can hypothesize our results and come to more concrete conclusions. We learned a lot from this project, and much of what we learned will help us to develop more sophisticated survey project research projects in the future.